Hello class, welcome to video number 11. This is our second video of our new unit, unit number 9, on acids and bases. This video we're not going to quite get to acids and bases yet, that's going to be next week, but we're working our way towards describing an acid and a base, and specifically what pH means. Now to describe what pH means, we need to know what concentration means, and that's what we discussed last video. In the last video, we learned about 4 different ways that we can describe concentration. This video, we're going to focus on one of those ways that we most commonly use in a chemistry class and a chemistry lab. That is molarity. So we use molarity to describe the concentrations of solution in chemicals that we use in a laboratory. At a grocery store, you don't typically see things in molarity. Okay, you see it in a percent or parts per million. Okay, typically I would say more commonly percents or maybe grams per liter. In a chemical laboratory, you see things labeled in molarity. So if you pick up a bottle of acids or bases or solutions, the bottles in a chemistry lab, and you've probably noticed this, have been labeled with like 1.0 with a capital M, molarity, okay, or 5 molarity. That is the concentration we use in a chemical lab. Now what I want you to do today is describe how do I make those solutions, so that someday you might be making your own. But first, let's do our quick warm-up to get us started. For today's warm-up, I want you to answer the question, what is molarity, how do you get it, and what is the label? So I said the label just a few seconds ago. Let's see if you remember. What is molarity, how do you get it, and what is the label? All right, so molarity is moles per liter. It's the ratio of moles of solute per liter of solution, calculated by simply taking moles divided by liters. And I label it with this capital M. So that's what you see on the sides of bottles in a chemistry lab. Capital M, meaning moles per liter. Okay? All right, so this class, when you leave here, you should be able to describe how to make a solution, how to describe what the concentration of that solution means in molarity, and there's going to be 2 ways we're making those solutions, using a solid or diluting a strong solution, and those are typically the 2 ways that I make solutions. Okay, sometimes I dissolve a certain amount of solid in water to make a certain molar solution. Or if I have a really strong, let's say, acid, and I want to make a weaker acid, I need to dilute it down. So those are the 2 ways we typically make solutions, dissolving a solid or diluting a strong solution. So how do we do that? I'm going to go over first a couple examples, and then we're going to do a few problems from today's homework. All right, the first problem. How many grams of sodium chloride are needed to prepare 1.5 liters of 0.5 molarity NaCl solution? So we need to make, our boss tells us, he needs to do an experiment, 1.5 liters of 0.5 molarity sodium chloride. Okay, I need to prepare that so that I can do a lab, or so that I have it. Okay, now I need to figure out how much solid do I need to dissolve to make that solution. Now in this case, you're going to be doing dimensional analysis, going from one unit to another. Now typically you're either going to be going from liters to grams or grams to liters. If in this case, because I'm going to grams, I'm going to start at liters. If I was going to liters, I would most likely be starting at grams. Now what am I using as a conversion factor, and that's what's a little different in this unit? This right here is a conversion factor, because remember, molarity, capital M, is moles per liter. So I can use that to convert from liters to moles or moles to liters. So my conversion factor here, remember when I did stoichiometry and went from grams to moles and things like that, that's the conversion factor, is going to be my concentration, because concentration is moles per liter. So if I start at liters, I want to get to grams. But in order to get to grams, I need to go to moles first. To do that, I first convert from liters to moles. This molarity I brought right down here and used as a conversion factor to go from liters to moles, because remember that molarity means moles per liter. So now I'm going from liters to moles, and I want to get to grams. To go to grams, remember, from moles, I need the molar mass. The molar mass is going to go on top of my last step, and now I have properly set up my dimensional analysis problem to go from liters to moles, from moles to grams. And what I end up with here is 43.8 grams. Okay? That's going to be one of, I would say, it's probably going to be about our 3 different types of problems. Okay, here I went from liters to grams. Another type of problem is here we're going from grams to liters. So I want to make a 0.2 molarity solution of sodium sulfide using 200 grams of solute. Now in this case, my boss is telling me make as much solution as you can. Make as much 0.2 molarity solution using the 200 grams of sodium sulfide that we have. We need to make as much as possible. So in this case, I'm figuring out how many liters I can make using my mass of solute. So in this case, I'm starting at grams. And because I can use, remember, this concentration, moles per liter, to get between moles and liters, I need to first get to moles. Okay? So it's kind of the problem we just did backwards in a way. So in this case, first I go from grams to moles. Remember, it's sodium sulfide. Okay, so this would be the molar mass of sodium sulfide. So I'm going from grams to moles. And now using this molarity, I can go from moles to liters. And I'm properly converting from grams to moles and moles to liters. So what I would do is if I mixed 200 grams of sodium sulfide with 12.8 liters of water, that solution can be labeled 0.2 molarity. Okay? All right. And those are the 2 types of problems we're going to be doing on worksheet 9.2. On worksheet 9.2 on the front, there are 3 different sections. Section 1, 2, and 3. And you'll see like 1, A, B, C, D, 2, A, B, C, D, and 3, A, B, C, D. Okay? Each of these are different types of problems. And then on the back, we have dilution problems. Okay? So we're going to do a one from each section to get you started. So in this case, this is more of a review. It's not so much the conversions we just did a moment ago. It's a review from calculating molarity like we did last video. So in this case, just calculate molarity. Remember, molarity is moles per liter. I'm given mass and volume. So what do I need to do with that mass? Turn to moles. Okay? Once I have turned my 30 grams of acetic acid to moles, to get molarity, remember, I divide it by my volume in liters. If I have 800 milliliters, how many liters is that? 0.8. So I divide the 0.5 moles by 0.8, and that gives me my molarity, 0.625. So in this first section, I'm taking my mass, turning to moles, and then dividing by my volume, remember, in liters, to get my molarity. And remember, I label that molarity with a capital M. Okay? All right, that's section 1. Section 2 is more like the problems we did a moment ago. In this case, I'm given a volume and a molarity, and I'm asked to calculate grams. So remember, when I'm given a volume and a molarity and asked to calculate grams, you start with your volume, but our volumes in this unit are always in liters. So because it says 750 milliliters, I move the decimal 3 places to the left to get it to liters. 1, 2, 3. So that's 0.75 liters, and now I'm going to convert to moles using this, because remember, 0.5 molarity is 0.5 moles per liter. That gets me from liters to moles. So now I'm figuring out how many grams of calcium chloride I need to make 0.5 molarity solution and 750 milliliters of that solution. So I go from liters to moles and then moles to grams using my molar mass. and there's my last step going to grams. So what I would do here is I would mix 41.6 grams of calcium chloride in 750 milliliters of water, and I could label that solution as 0.5 molarity. All right, that's section 2. Section 3, the last on the front. To make a solution of the following concentration using the grams of solute given, how many liters of solution would be needed? So in this case, I'm given mass and molarity and asked to go to liters. So remember, if I'm given mass, I start with mass and first go to moles. I use this molarity to get between moles and liters. But in order to use this molarity to get between moles and liters, I first need to go to moles. To go to moles, I divide by the molar mass. The molar mass of sodium hydroxide, NaOH, is 40 grams. That molar mass goes on the bottom, and that has taken me to moles. Next, I want to go to liters. I can use this moles per liter to get to liters, remembering the mole part is going to go on bottom. So the 2 moles per liter, the 2 goes on bottom because this means 2 moles per liter. So now I've successfully converted from grams to moles, moles to liters, and what I am left with is the unit that I want to go to, liters. So if I mixed 80 grams of sodium hydroxide in 1 liter of solution, I would label that bottle as 2 molarity. That is what this is saying. All right, let's do one quick practice problem before we learn about dilutions on the back. All right, so here's your quick practice problem where I'm seeing seeing your understanding. I'm going to get you started, you're going to finish, and click your answer on the side. Calculate the grams of solute in the following solution. So in this case, I'm starting at volume and going to grams. So why don't you take a minute, pause the video, and try to answer the question. All right, so if I'm starting at volume and going to grams, I start at liters. 500 milliliters equals 0.5 liters. I'm going to grams, so first I need to go to moles. I can go to moles from liters using my concentration. Remember, the 0.75 molarity means 0.75 moles per liter. So that takes me from liters to moles. Next, I have one more step, going to grams. Going to grams of sodium chloride, I need the molar mass, which is going to go on top to take me from moles to grams. So in this case, I multiply 0.5 times 0.75, multiply that by 58.44, and I end up with 21.92 grams of sodium chloride. So if I mix 21.92 grams of sodium chloride with 500 milliliters of water, that solution is going to be 0.75 molarity. All right, so that's making solutions using a solid. The other way we can make solutions is diluting an already strong solution. And you've probably heard this before. This Kool-Aid's too strong, or this coffee's too strong. Let's dilute it. What am I asking you to do? Add water. So why is this important in chemistry? Because to save time, space, and money, I can purchase really strong solutions that I dilute down when needed to use in a lab. So if I, need a bunch of 0.1 molarity acid throughout the year, I don't need to buy a bunch of 0.1 molarity acid from the store, from the chemical supply company. I can buy a really strong version of that acid and then dilute it down to use as necessary. So I don't have to fill my cupboards with this weak solution. I buy very strong stuff and then dilute it as I need it. Okay? So we dilute to the desired concentration when I use it in a lab. And this is most often done with acids, sometimes bases. Okay? So to quickly and easily figure out how much water must be added, we use a dilution equation. So this is a lot like Boyle's law equation, but instead it's using concentration. And I would write this down. Not that, I would write M. They're the same thing. Sometimes you'll see it as C, standing for concentration. More often you'll see it as M. So the dilution equation, which I would write down somewhere, is M1 times V1 equals M2 times V2. Meaning, if you change the volume, if the volume goes up, the molarity goes down. This has an inverse relationship, just like pressure and volume. So molarity and volume have an inverse relationship. So this equation is we're going to use to solve problems on the back of worksheet 9.2. M1 times V1 equals M2 times V2. All right, let's do a problem. So problem, what volume of stock 11.6 molarity hydrochloric acid? Typically, I refer to stock as the really strong stuff. So if I buy stock acid, okay, I'm buying as strong as acid as I can get. And then I'm going to dilute it down. So what it's asking is what volume of this, okay, what volume of this do I need to prepare 250 milliliters of 3 molarity hydrochloric acid? So I want to dilute my stock acid, my strong acid, down to 3 molarity, but only 250 milliliters of that. So I label my variables. Now these two go together, so you can really call them what you want, M1 and V1 or M2 and V2. It's up to you. Just keep the ones that go together. Okay, in this case, I labeled these, because it's what I'm going to, as M2. This is M2, and this is V2. Okay? And this is my M1. So I'm figuring out what volume of this, okay, do I need to make this. Okay, so I'm plugging everything in. Now, do you really need to convert to liters? No, but it's in good practice that you're always working in liters, because that's going to be the more common unit that you use this unit. Okay, it's up to you though. You could also work with milliliters here. So my M2 is 3, my V2 is 0.25, my M1 is 11.6. I'm calculating V1. How do I calculate V1? I divide M1 over. And when I do, I end up with my volume. So it looks like I need 0.065 liters of my strong solution. Then I'm going to add enough water to get up to 250 milliliters, and then I can label that new solution as 3 molarity. Okay? So I would measure 65 milliliters of the strong acid, and then add enough water to make it 250 milliliters, and then I can label that new solution as 3 molarity. Okay? All right, let's do a couple homework problems from worksheet 9.2, diluting. If I add 25 milliliters of water to 125 milliliters of a 0.15 molarity sodium hydroxide solution, what will the molarity of the diluted solution be? So number 1 on the back of worksheet 9.2. If I add 25 milliliters to 125 milliliters of 0.15 molarity sodium hydroxide, what will the new molarity be? So here I'm diluting it. Okay? So I can call, it looks like I'm starting with 0.15 molarity sodium hydroxide, 125 milliliters of that, and then I'm adding 25 milliliters. So I'm going to call this my M1 and this my V1. Okay? I'm adding 25 milliliters, so my V2 is going to be 150. And I'm looking for that new molarity. So I'm simply solving for M2. When I do, I divide by 150, and I get my new concentration, 0.125. All right, number 2. Before I get too far, this brings up a safety issue I wanted to address. When you're doing these dilutions in real life, you're not adding the acid to the water. You're always You're not adding the water to the acid. You're always adding the acid or the base to the water. Just because it is an exothermic reaction, so you want to do it as carefully as possible, and you don't want it to boil over. So when I'm doing these dilutions, I'm always adding that acid to the water. Okay? So if I add 100 milliliters of 0.15 molarity sodium hydroxide until the final volume is 150 milliliters, what will the molarity of the diluted solution be? So I'm adding water to 100 milliliters of a 0.15 molarity sodium hydroxide solution until the final volume is 150 milliliters. All right, so I can just label my variables and use this equation. Looks like my M1 is going to be 0.15, my V1 is 100, and my V2 is 150. I'm solving for my new concentration, rearranging that equation and labeling my new concentration as 0.1. It has gotten weaker because I have added some water. All right, one more problem, example problem number 5. How much water would I need to add to 500 milliliters of a 0.25 molarity potassium chloride solution to make a 1 molarity solution? So in this case, I'm seeing how much water, so I'm looking for V2. All right, my M1 is going to be 2.4. My V1 is 500. My final concentration I want to be 1 molarity. That's my M2, and I'm looking for V2. When I do, I rearrange and solve, and I get 1200. But that is not my final answer. Because the question says, how much water do I need to add? This is my final volume. How much water do I need to add to this 500 milliliter solution to get to this? 700. So because the question is asking, how much water do I need to add? I need to take into account the volume that I already started with. This is your final volume, but I started with 500. So how many milliliters did I add? 700. Notice I just left it in milliliters. It's okay if you did it in liters. Either way is fine as long as they're both the same. Both sides are the same, V1 and V2. All right, so that is some examples of describing how to make a solution using a solid and diluting. And that was our goal for today. Today's homework is to do worksheet 9.2. The front is on molarity calculations and the back is on dilutions. Please take your time and do those problems and turn in your worksheet when you're done. Good luck, and let me know if you have any questions. I look forward to seeing you.